Dear students, today we discuss how to convert your digital binary values to the staircase pattern waveform. Okay, so before we are going to the logic, first you see this is a way how the circuit is connected. So you can see this is your microcontroller. It is connected with the DAC IC, the DAC 080. It's a 8-bit DAC. So you can see the port 1 is connected to D0 to D7 pins. Here you will get the current values that by using I to V converter, it convert your current into the equivalent voltage. So this is the output in analog. Okay, this is the way how the circuit is arranged. Okay, now we need to have a staircase. Okay, what is a staircase waveform? Okay, it is something, it's something like a resemblance of staircase, something like a resemblance of staircase due to the step value. There is a step value transition between the discrete values, not like a smooth waveforms, right? So it is resemblance like a staircase due to the that stepwise transition. Okay, that you need to understand. So let me explain. See here, so this is a staircase wave. Okay, here you can understand here it increment or it may decrement. Here I shown only the increment pattern. This is a staircase pattern. It increment by fixed steps. This fixed is a fixed steps. Okay, this you need to understand. This is a staircase, it's a fixed step. Before you are going to write the program, first we need to see what is the step you required based on your requirement. Here I taken the steps of 51. Okay, 51 in decimal and 33 in hexa. That means this is 0 to 51, then next value will be 102, then next value will be 153, and next value will be 204, and next value will be 255. So this is a step I fixed. Okay, so you can see here, first the accumulator will loaded with the value 00h, that is 0 in decimal. Then during the first addition I need to add the value with 33h in hexa, 51 in decimal. Then you have a first, second, third, fourth. So you can see this pattern. Okay, this is a first, second, 3, 4, then 5. So in first transition you can see the first step 0 to 51. So we'll draw. So 0 to 1, 2, 3, 4, 5. 0, this is 51, the first process. Then here it is 102, 102. Here 153. Then it is 204. Then 255. Here you can see the steps are fixed. Okay, so before you write the program, you need to fix the step. Accordingly, you need to write the program. You want to load the value in the accumulator. Okay, now we will go for the program. See, now I am loading the value to the accumulator, that is 00h. Okay, so now accumulator register is loaded with the value of 00h. Okay, that is the first instruction will do. Then the whatever content in accumulator, that will be transferred to port 1. Now see, I said I need a step of 51. So every time accumulator now hold 0. Now it will be added with 51. The content of accumulators is moved from A to 50. That means you will get step like this. You get this step the first time. Then see, compare jump if not equal. So whether 51 is equal to 255? No. Then it will go to the label to RPT. Then it will repeat the process. So first time 51, then 102, then 153, 204, 255. Once this accumulator hold the value of 255, it will check 255 is equal to 255, then condition fail, it comes out. So that means you got the step pattern of the staircase with the 5 step. Why 5 step? Because I have loaded with the 51. So 0 to 55 is a maximum for the 8 bit. 2 power 8 is 256. That means you can go from 0 to 255. If you take 51 as a step discrete value, so you can have only the 5 steps, 1 2 3 4 5. So if step is vary, you can go for n number of steps also. Okay, it's based on your what is the condition you want to write. So this is a logic of a program. Okay, so then after going to this short jump staircase, it will go into this label, and again it will start the process of creating the staircase waveform. Okay, I hope you understood. Thank you.